All right, so let's just start with something relatively straightforward, like a half and a fourth. Now, the problem with fraction addition, I'm going to go ahead and put the 4 operations up here. Operation is just a fancy word for a math task. Addition, subtraction, multiplication, division. I'm splitting them into 2 parts because in most things in mathematics, addition and subtraction go together and multiplication and division go together in terms of how we do them. So if I want to add a half and a fourth, the problem is that I'm not talking about the same thing. What I would point out is that this top number, the fancy word is numerator, that's just a counter. That says how many are there. And the bottom number is denominator. That's the fancy word for name. So a more visual way of thinking about this, I'll use a circle as a whole, as a representation of a whole. I have one of these things, which is a half, and I have one of these things, which is a quarter. So I have a half and a quarter, and I'm adding them together. The problem is that with addition and subtraction, it doesn't make sense to add things that don't have the same name. If I have 2 dogs and I want to add 3 cats, what the heck does that add up to? 5 dog cats? How do you do that math problem? What's 2 dogs plus 3 cats? That's a hard one, huh? A big animal fight? A disaster? Well, I've got 5 something, right?
Yeah.
5 what?
Five animals.
5 animals, 5 pets, right? I could put these together. It's not a problem for me to put them together, but I have to change the name, right? Because dogs and cats are talking about different things. And addition and subtraction doesn't make sense if you're talking about different things. 2 animals and 3 more animals is 5 animals, right? So the same thing happens with fractions. It's more complicated because it involves mathematical thinking. I can't just change the name to whatever I want, but that's the concept. What I'm going to do here with my half is I'm going to scale it up so that it's communicated in terms of fourths. So a half is the same as 2 fourths. Now I'm in business, because if I have 2 of something and I have 1 of something, then it's pretty easy to put it together. What do I have?
Are you asking for the answer or?
Yeah, what do I have?
Oh, 3/4.
Yeah. Right, which is 3 of these things, right? These little quarter pieces.
Mm-hmm.
So that's what's happening when I add fractions. And I'm sure you're going to get harder problems than that. So for instance, I'm going to go ahead and clear this screen. You might have something like 7/5 plus 3/10. Okay, that's a harder problem. How do you get these numbers to match? This is what we call finding the common denominator. Now, don't put extra pressure on yourself. There's not like one right answer to this. There's lots of common denominators that you could choose.
Yeah. We always usually go with the smallest one, right?
Yeah, if we can, we would find the lowest common denominator. That's nice.
Could be what, 2?
2 would be a multiplier to get me to the common denominator, which is 10. So if I scale the left side up by 2, then I'm talking about 14/10 and 3/10. And that makes 17/10.
17/10. Yeah.
Okay? So a lot of times the most direct way is to find a multiplier that will scale up one of the fractions so that it's the same denominator as the other one. Sometimes that's not possible. Sometimes when you're dealing with 3/2 and 5/3, There's nothing I can multiply 2 by, well, at least not a whole number, that'll make 3, and nothing I can multiply 3 by that'll make 2. So then I can just multiply the one by the other. As long as I multiply the top and the bottom of the fraction by the same number, I'm still talking about the same quantity, right? What I mean by that is a half is the same as 2/4. It's the same as 3/6. It's the same as 4/8. There's lots of representations of a half. So as long as I multiply the top and the bottom by the same thing, I'll end up with an equivalent fraction. So this is 9/6 and 10/6, and that would make 19/6. Okay? Subtraction is exactly the same. It's not a different process. It's the same thing. I need to find a common denominator so that I can bring the two things together. All right? Let me give you a couple practice problems here, just in case you have any questions. Okay, I'll give you a minute for that. Don't say your answer out loud. Just see what you can come up with. And then about 12:05, we'll talk. So what's the easiest way to get the denominators to match on this first one? Or what's a way?
4 times 5, 20.
Yeah, 5.
Yeah, 5 is a good choice, right? You multiply 5 top and bottom. I tend to rewrite these just to eliminate mistakes. Right? One of the things that you're going to want to get into a little bit is about the kinds of mistakes that you make. I'll show you an example of one of the classic mistakes that students tend to make here in the next one. Okay, so yeah, once we change it to 20ths, then we can just subtract. If I have 13 of something, I take away 5 of it, I got 8 left. This could be simplified, by the way, and I don't know whether Pearson cares about that kind of thing, but 8/20ths is not the simplest version of that fraction. I can divide this by 2, and I can divide this by 2. That makes 4/10. Can 4/10 be simplified?
Yep.
Yeah.
2 over
Go
5.
again, right? Yep. We can divide again, and we end up with 2/5. This is what I would call the simplest answer, the reduced answer. That's not to say that this is wrong or this is wrong. These are all the same thing. It's the same quantity. But from a mathematical perspective, sometimes we want the simplest version. Okay, what about this next one?
4.
Uh-huh.
The 11/8.
I got 7 plus 5 equals,
Why do you have 5?
yeah, where did 5 come from?
It would be 4.
Yeah. So this is what I would call misfire. Misfire is the kind of mistake where you tell your brain to do something and it comes out with something related, right? Maybe my brain just for a second got confused between multiplication and addition. I don't know. It happens. It happens to people all the time. You're not a computer, right? And I'm not encouraging you to type 1 times 4 in your calculator. You don't need to, right? But when you use your brain and you do things mentally, you're going to make mistakes. And some of us have a higher error rate than others, right? My error rate is really low because math is my life. I do it all the time. What is your error rate like, right? That depends on how sharp your mental math is. What's 2 plus 7? What's 9 plus 4, right? You could kind of test yourself on those things, but that's something to keep in mind. You get the problem wrong in math, it doesn't mean you don't know what you're doing. It could mean you just made a little mistake. So this should have been 4. So this is 11/8. Okay? That's a very common type of mistake that people make in math. It's called a misfire. It's when you tell your brain to do something, but it comes back with a different operation result. Now, just because I saw some mixed numbers in the warm-up quiz, this can be turned into a mixed number because 11/8 is 8/8 and 3 more 8s. Why did I break it into 8 and 3? Because 8/8 is special, right? Once I have 8/8, that means I have a whole. So this is 1 and 3/8. There's different techniques to turn what are called improper fractions, this is improper, into mixed numbers. There's not one that's better than the other. They both have value and purpose. Mixed numbers are easy to see on the number line. If I tell you to measure something that's 1 3/8 of an inch, you know it's somewhere between 1 inch and 2 inches. You don't have to think about it. If I tell you to measure 11/8 of an inch, you might have to kind of stop and think about where is 11/8. On the other hand, 11/8 is very easy to multiply and divide. 1 3/8 is not easy to multiply and divide. So if I have to do 7 measurements of 11/8, then the total is easier to figure out when it's in its improper form. Okay?
So where did you get the 3 from?
Yeah, where did the 3 come from? Well, the way I did it here is I just split 8/8 and then I thought, well, what's left over? So in my mind, I'm doing 11 minus 8. That's where I get the 3 from.
Right.
Now, typically, the process that most people use looks more like this. If I have 35/8 and I want to turn it into a mixed number, I'm going to divide 35 divided by 8. Go ahead and do that either in your head or in your calculator. And I'm interested in what's the whole part? How many wholes can I get out of that? If you do it on your calculator, you're going to get something, point, something, something. All I care about is the thing in front of the point.
4.
4 point something, something, right?
Yeah.
So instead of writing the point, what we're going to do is 4, and then we're going to write this other fraction. So the question is, 4 is equal to what?
3/7. 8.
So that's 32/8.
I don't see you guys.
So in other words, when I divide 35 by 8, I get 4 with a remainder of 3. And this remainder of 3 goes here.
All right, I can't. I don't know why I can't get to that.
This is 4 3/8. That's the process for turning an improper fraction into a mixed number.
Mr. Davis,
Okay.
you said that you couldn't get an IRED, which I understand. Nobody could get into the IRED yet.
I'm gonna go ahead and mute Lamont. Yeah. Sometimes if there's background noise stuff going on, I'm just gonna mute you to make sure it doesn't get in the way of our class. But that's an example. I mean, this is complicated, guys. If you guys have family members, and I know a bunch of you got kids, you know, you're gonna be dealing with mixed spaces and trying to do multiple things at once. That's just gonna be a challenge that we all have to kind of figure out. Okay, so we got 4 3/8. That was changing an improper to a mixed fraction. One more thing I want to show you with fractions, which is multiplication and division. Now, by the way, this stuff is recorded, and so I will post this later in an announcement so that if you want to go back and look at this video again, you can stop it, pause it, slow it down, replay it. Okay, let's say I have 11/8 and I want to multiply it by 5. How do I do that? So multiplication and division are different. We don't need a common denominator to do this. If I had 11 cows and I wanted to multiply it by 5 for some reason, that would be 55 cows, right?
Mhm.
So in other words, I just need to multiply the top by the 5. The bottom doesn't change. Now, mathematically, what I would say is this. When you multiply, first of all, make sure both things are fractions. And second of all, just go straight across. Multiplication is exactly the way you would want things to work. You just multiply straight across. You got a half times a third, multiply straight across. It's 1/6. You got 2/7 times 3/4. Multiply straight across. What would that be?
6/28.
Something.
Exactly.
Do you put on arithmetic, man? Yeah. Well, how come I'm seeing
And from there, then we can
that way?
divide to simplify if we want to. I don't know if that's necessary or not necessary all the time. Okay. So that leaves us with one operation. 18 divided by 3/4. Now, I kind of blew past turning the 5 into a fraction. Anytime you have a whole number, you can make it a fraction by just putting it over 1. Okay. Now, it turns out that multiplication and division are the same in the way that addition and subtraction are the same. You can divide straight across. The problem is that division is not forgiving. I can do 18 divided by 3, no problem, but 1 divided by 4, that's not as nice, right? That's a fraction. It's not an even thing. So there's a way that most people deal with this, which is, and I use the mnemonic, which is keep, change, flip. You keep the first part, you change the division to multiplication, and you flip that last fraction. Now, if you want to know more about why that works, we could talk about that on the side. Some people are interested in that kind of thing. They don't want to just have the technique, they want to understand it. And some people are like, don't give me the details, just tell me how to do it, man, and then I can do it. That's kind of a personal thing. So from there, 18 times 4 is 72. 1 times 3 is 3. In this case, I can actually divide 72 divided by 3, and that gives me 24. So that's the answer. This type of problem pops up when you're taking something, let's say you have an 8-foot board, which is 96 inches, okay? And I'm just gonna write out a little word problem here. Okay? So this is the kind of problem where now we're moving beyond just doing a little bit of math to like having to read the problem and do the work and then come up with an answer that makes sense for the situation, okay? So this is basically just a fraction division problem, but it's got quite a few wrinkles in it. First of all, the length of the board is given in feet, but I want to cut these into pieces that are in inches. So the first thing I would do is make sure we change this 8 feet mentally into the inches. And I already said that number out loud. We're going to talk more about ratios later, but how many inches is that?
96.
96 inches. Okay. So basically this turns into what is 96 divided by 7 3/4. Now I could do this as a decimal, right? Because 3/4 can be represented as a decimal, but I'm going to talk about it in fractions, and we can look at the decimal version later as a way to kind of check ourselves. Like I said, multiplying and dividing with mixed numbers is not easy. So actually one of the first things I want to do is I want to change this into an improper fraction. So it's the reverse of what I did, changing an improper fraction into a mixed number. Does anybody remember how to do that? How to change?
Multiply 74 and then add 3.
Good. Okay. Some people call that the check up approach. And the reason they say that is because you're kind of going down here and then up here. So you multiply 7 times 4, and then you add on the 3. So that's 31/4. So this is 96 divided by 31/4. Okay. So what's the process for dividing 96 by 31/4?
It'll be 96 times, 96 times 4 over 31.
And all I would add to that is putting this over 1 so we can see it's a fraction. Okay? And from there, we can just multiply straight across. That's what's beautiful about multiplication. So what's 96 times 4?
384.
What'd you say? 304?
384.
384. And 1 times 31 is just 31. From here, notice that this is not a good answer. I said, how many pieces can I make? So I'm not interested in 384 31st. I want to know, am I going to make 5 pieces, 10 pieces, 20 pieces?
12 pieces.
So if you take 384 and you divide it by 31, you get 12 point something, something, something. And the important part
12.3.
is that you can make 12 whole pieces. This extra part here is not really relevant, since if I can't make a 7 3/4 inch piece, I don't want to
Yeah,
know.
you don't need that extra.
I don't care about it. I'm going to throw it out. Okay. Okay, so there's a real world example of doing some fraction division. Like I said, this could be done with decimals, because 96 divided by 7.75 is going to give me the same answer, and it's a little more direct way to do it. So if I was really on the job and I was trying to do something like this, I would probably just convert it into decimals. But all of that requires a little bit of mathematical flexibility and confidence. Like, you know what you're doing, you feel good about the numbers, and you can work with it. And that's a big part of what I want to give you in this course, is just some time to work with numbers and feel more confident about your interaction with them. Because whatever you guys are working in, numbers are going to be a part of it. That's part of being in the tech field. Okay, I'm going to be quiet for about 20 minutes, let you guys work on some stuff, and then I'm going to end the course a little early today. I want to go over some of the info sheet answers, because I think it's nice to see a little bit about who your classmates are. I'm going to close that up.